Hello everyone. Today we are going to take the second lesson, that is polynomial. The polynomials lesson you have studied it in the 9th standard also. So you know the basics what is the polynomial. Polynomials are the expressions where the coefficient should not be negative and it should not be in a fraction form. What is a polynomial? Just we'll revise it what is a polynomial and then we'll start it. The polynomials are the expression where the index is not negative and it should not be in the fraction form. For example, suppose this is p of x. P of x means polynomial of x if the polynomial is in the x form. That is, suppose x square minus 2x plus 3. Yes, this is a polynomial. But if the polynomial degree, if the coefficient of this is negative, suppose it is minus 2, half plus 3, then this is not a polynomial. This is not a polynomial. Why? Because here it is negative and here it is in fraction. So what is a polynomial? When the index form of a given expression is not negative and it is not in a fraction form, this is known as a polynomial. There are many types of polynomials. टाइप्स ऑफ पॉलिनोमियल्स हैं, कांस्टेंट पॉलिनोमियल है, जीरो पॉलिनोमियल है, लीनियर पॉलिनोमियल है, क्वाड्रेटिक पॉलिनोमियल है, cubic polynomial and biquadratic polynomial is also there. So what are there are how many types of polynomials? Types of polynomials. So first one is constant polynomial. Constant polynomial. What is constant polynomial? Where only there will be a number, that is, for example, p of x is equal to 8 or f of x is equal to 4. This is known as the constant polynomial. Here also in this is a constant polynomial where we don't have a variable. Now actually there is a variable, that means 8x raised to 0. What you get? 8 into x raised to 0, anything raised to 0 is 1, and 8 into 1 you get 8. So the degree of this polynomial is 0. The degree of the constant polynomial is 0. The degree of the constant polynomial is 0. The next polynomial is zero polynomial. Where the polynomial itself is 0. There is nothing, it is 0. Or it can be this way also, 0x square. Okay. Next one is linear polynomial. What is linear polynomial? The degree with 1. The polynomial of degree 1 is called a linear polynomial. The polynomial with degree 1 is called a linear polynomial. That is 2x plus 3. Here the degree of this, here it is 1. So degree of this polynomial is 1. And the standard form of this is ax plus b. The standard form of this is ax plus b, where a and b are real numbers and a should not be equal to 0. So this is known as linear polynomial, where the degree of the polynomial is 1. What is quadratic? The name itself you come to know quadratic. That means the degree of this polynomial should be 2. The degree, I'll write it here, degree should be 1 and the degree of this polynomial should be 2. Example, p of x is equal to 4x square minus 7x plus 3, or p of y is equal to 4y square minus 3. That means the standard form is ax square plus bx plus c equal to 0. The highest degree should be 2. It should not be more than 2, and the um, 0, a should not be equal to 0, where a should not be equal to 0. A, b and c are real numbers. A, b and c are real numbers. So what is a quadratic polynomial? The polynomial with the degree 2 and the first polynomial, that is a, should not be equal to 0. That means x squared, the coefficient should not be equal to 0. Because if it is 0, then it is not a quadratic polynomial. See here. Suppose I have tell it 0x square minus 7x plus 3. The first term itself is 0. Then what is remaining? That is minus 7x plus 3. So this is not a quadratic polynomial. The next one is cubic polynomial. That is cubic polynomial. What is cubic polynomial with degree 3? What is cubic polynomial with degree 3? The standard form of this is ax cube plus bx square plus cx plus d is equal to 0. So the standard form of this, and your a should not be equal to 0. Same thing. If a is 0, then your polynomial becomes bx square plus cx plus d. You don't have a cube, x cube, then it is not a cubic polynomial. So with degree 3, it is known as a cubic polynomial. It can be anything. Example is 3x cube minus 7x square plus 3x minus 5 equal to 0. The degree 3. Now, you don't have this, actually this is the extra I am telling you. You learn it in the next year. That is biquadratic polynomial. That is biquadratic, and the biquadratic polynomial. Now you come to know that biquadratic is degree 4. Again, the standard form is ax square, ax raised to 4 plus bx cube plus cx square plus dx plus e is equal to 6. So this is the biquadratic form, but you are not going to learn this year. You are learning the next year, where a should not be, again here a should not be equal to 0. This is known as a biquadratic polynomial. And a, b, c, d, e are real numbers. Now what is the value of the polynomial and the zeros of the polynomial? Value of the polynomial and zeros. What is this? Value of the polynomial. Value of the, if p of x, they have given us the example x cube minus 3x minus 4. And if by putting x equal to 2, if you put x equal to 2, that means x, the value of x is 2. Put on the value of x, substitute the value of x here. That is 8 minus 6 minus 4. And what you get is 8 minus 6 is 2. And 2 minus this is x equal to 2. If you put the value, what you get? Oh, it is square here. So anything, if you take cube also, it is no matter. So it will be 4. You get the value p of 2 is minus 6. That means the value, just keep in mind, the value is minus 6. So when you put the value, when you substitute the value of x, what the answer you get, that is the value of the given polynomial. That means if p of x is a polynomial and k is any real number, then the value obtained by replacing x by k, then the value of p of x at x equal to k. Okay, and instead of p of x, it is denoted as p of k. Now what are the zeros of the polynomial? What are the zeros of the polynomial. Zeros of the polynomial is the value of the polynomial when you substitute something x equal to something, then this value what you get is 0, then the number what you have substituted, that is known as the 0 of the polynomial. That is known as a 0. Suppose the same question we will take it, that is x square minus 3x minus 4. X square minus 3x minus 4. And if you put p of minus x, minus x, instead of x, you put x equal to minus 1. Now what you get? Minus 2, minus 3 into minus 1, minus 4. That is 1 plus 3 minus 4, and you get 0. Then minus 1, listen here, minus 1 is the 0 of the polynomial. Okay? When you get the answer 0 of substituting something instead of x, y, then the value what you substituted is known as the 0 of the polynomial. Suppose I'll substitute here p of, instead of x, I'll substitute 4. So what I get? 4 square minus 3 into 4 minus 4, and that is 16 minus 12 minus 4. Again you got 0. Then your 4 is the 0 of the polynomial. 4 is the 0 of the polynomial. Now, so what are the highlighted points here? Every real number is the 0 of the 0 polynomial. Every real number is the 0 of the 0 polynomial. But see here, x square plus x plus 1. This is your quadratic polynomial. How you are going to find the zeros of the quadratic polynomial? By your middle term splitting. Just recollect it. You have done in the 9th and 8th also. That is middle term splitting. But there are some quadratic polynomials where you cannot have two zeros. But there exists some quadratic we do not have any real zeros. For example, this. That is x square plus x minus 1. Every quadratic polynomial can have at least two zeros. But there exists some quadratic polynomial which do not have any real zero. That is, the example is this. So, now before going to other this, we are going to get a geometric meaning of the zeros of the polynomial. Geometric meaning. What we are going to do is geometrical meaning. What is geometrical meaning? Your linear polynomial, that is ax plus b, where a is not equal to 0. We know that the graph of this is y is equal to ax plus b is a straight line. What we know is a straight line. The linear equation, the standard form of the linear equation is ax plus b, and the graph of this is y is equal to ax plus b is the straight line which intersects the x-axis at exactly one point. That is, see here, ax plus b equal to 0, ax equal to minus b, and x is equal to minus b upon a. So it intersect exactly at one point. I have said it that linear equation has the degree 1. So it exactly intersect at one point. Has exactly 1 0. Therefore, linear equation, linear polynomial. We'll write it here, linear polynomial. Linear polynomial has exactly one, highlight this, okay. They have given us the example. Consider the first linear equation. This, that is y is equal to 2x plus 3 is a straight line passing through the point. They have substituted x equal to something, then you get in this way. Y is equal to 2x plus 3. They have taken x equal to minus 2. See, minus 2 plus 3. You get minus 4 plus 3, and that is minus 1. X equal to 2, you get plus 2, plus 7. And when you when you show it on the graph, what you get, see here, exactly here, you get an intersecting point. We are seeing here x-axis, no? So, what is the intersecting point? That is minus 3 upon 2 and 0. So, for our linear equation, there is exactly 1, 0, and the equation is minus b upon a equal to 0. Thus, the 0 of the polynomial, this is the x-coordinate of the point, x-coordinate of the point, where the graph of y is equal to 2x plus 3 intersects the x-axis. So, from this, what you come to know? That we see the x-coordinate of the point. We see the x-coordinate where the graph intersects the x-axis. Now, linear equation. Linear polynomial, they have told us again. Now, let us consider the quadratic polynomial. Quadratic polynomial has a degree 2. Therefore, they are having the zeros 2. What is that? That quadratic polynomial. They have degree 2. That means the zeros they have is 2. So, they have 2 zeros. We will show it how they have 2 zeros. They have taken one example, that is y is equal to x square minus 3x plus 4. And they have taken this much of values. And just they have put it on the graph. They have shown it on the graph. Now from the graph, what you see, that it intersects at x-axis at the point that is minus 1, and here it is 4. And as it intersects on the x-axis, that means your y is 0. That means your y is 0. Any quadratic polynomial, the graph of the corresponding equation has two shapes. And one more thing, the graph of the equation has two shapes. It either have upward opening or it either have the downward opening. Upward opening and downward opening. That is known as the parabolas. And that is known as parabolas. Now you can see from this, the table, that it has got minus 1 and 4 are the zeros of the quadratic polynomial, they have said. So the zeros of the quadratic polynomial where get intersect at x-axis. So how many zeros? So it is a fact. This fact is true for any quadratic polynomial. Zeros of the quadratic polynomial is 2. Actually, it depends on the degrees. Linear polynomial has 1 degree, so the zeros are 1. 0 is 1. The quadratic polynomial has 2 degree, the zeros are 2. The cubic polynomial will have 3 degree, and so the degree will be 3. Okay. Now, in quadratic polynomial, they have 4 cases can happen. What happens? 4 cases. The first, 3 cases. First one is, the graph cuts x-axis at 2 points. The graph cuts x-axis at 2 points. They have given us, that is A and A dash. A and A dash. So, the zeros are 2. It may be upward or it may be downward. Now, as it is this, your A is less than 0, and here your A is greater than 0. A is less than 0. When it is downward, then your A is less than 0. And when it is upward, your A is greater than 0. What is the case 2? exactly at one point. The graph cuts the x-axis at one point at two coincident points. So your A and A dash are the same point. Here also same thing. As it is downward, A is less than 0 and here it is 8. So A is the only 0. Case 3. What I have shown in the case 3. The graph is either completely above the x-axis or below the x-axis. So it does not cut the x-axis. That means you don't have any zeros. When it cuts the x-axis at 1 point, 2 point, 3 point, that means they have that much of zeros. But as it is above the x-axis and as it is below the x-axis, it doesn't have any zeros. So no zero in this case. So how many cases we have done? We have done till now 3 cases. In first case, we had 1 0. We have 2 zeros in first cases. That is x axis la दोन हे कट होता है. And second case, x axis at the graph cuts the x axis at exactly 1 point. So have 1 zeros. And in third case, it doesn't cut any axis. It is completely above the x axis or below the x axis. So it doesn't have any zero. You can see geometrically that the quadratic polynomial can have either two distinct zeros or two equal zeros. That is 1 0 or no zero. That means the quadratic degree 2 has at most 2 zeros. So what I said is degree 2 has at most 2 zeros. So degree 3 will be having at most 3 zeros. And so on. Now they have given us a cubic polynomial. They have given us a cubic polynomial, y cube minus 4x. See here, the graph has cut the x-axis at 3 points. The first point is minus 2 and 0, this is 0, 0, and the third point is 2 and 0. Since the curve meets the x-axis in only 3 points, the x-coordinates are the only zeros of the polynomial. Let's take a few examples. Consider the cubic polynomial they have given us. See. Note that 0 is the only 0 of the polynomial because it has intersected here and here it has intersected in 3. So you can see that where the graph of y equal to x cube intersects the x-axis, and since x cube minus x square, that is 0 and 1, are the only zeros of the polynomial. Examples. Each is the graph of y equal to p of x, where p of x is a polynomial. Find the number of zeros of p of x. Here the number of, as it intersects the x-axis, cuts the x-axis at 1 point, so number of 0 will be 1. Here it is 2, so 0 will be 2. Here 1, 2 and 3, it will be 3. Here again cuts the x-axis 1. Here also 1. Here 1, 2, 3 and 4. So just you have to look where the y equal to something has given and where it cuts the x-axis. Then comes your example, exercise 2.1. That is, they have given us find the number of zeros. Same thing. Here no zero because it has not cut the x-axis. Here 1 0. Here 1, 2, 3 zeros. See here it has cut the x-axis at 3 points. Here 2 zeros. Here 1, 2, 3, 4 zeros. And here 1, 2, 3 zeros. Okay. Now, relation between the zeros and the coefficient of the polynomial. Relation between the zeros and the coefficient of the polynomial. For linear equation, for linear equation, I'll write it, for linear polynomial, for linear polynomial, if k is the 0 of p of x, if k is the 0 of p of x, if k is the if k is the 0 of p of x, that is ax square plus b, where your a is not equal to 0, then p of k will be ak plus b. Okay, therefore ak plus b equal to 0, ak is equal to minus b, and k equal to minus b upon a. K equal to minus b upon a. That is, what is your minus b upon a? That is minus, b is your constant term, b is your constant term, okay, upon, what is a? Coefficient of x. A is coefficient of x. Now for quadratic polynomial. Quadratic polynomial, what is the general form of the quadratic form for polynomial? That is ax square plus bx plus c equal to 0. And we know that quadratic polynomial has two roots. So let the roots be alpha and beta. Let the two roots be alpha and beta. Before 9th standard and 8th standard, you have done the middle term splitting. You may get some values, that is x minus something, that is alpha, and x minus beta. For example, we will take the same example. The earlier what they have taken is, what was the example for quadratic polynomial? It was x square minus 3x plus 4. It was x square minus 3x plus 4. Minus 4. X square minus 3x minus 4. So factors of 4 is x square minus 4x plus x minus 4, you get minus 3. X minus 4 plus 1, x minus 4, and x minus 4 and x plus 1. In this way you are getting the middle term splitting. So same way I have written it. X minus alpha and x minus beta are the x minus alpha and x minus beta are the roots of the quadratic polynomial. Okay. So what you are going to get is ax square plus bx plus c is equal to k. K is any constant. X minus alpha and x minus beta. Okay. Keep k as it is and just simplify binomial into binomial. Get the answer. That is x square minus alpha plus beta x plus alpha beta. Okay. Where k is some constant. What do you get? Kx square minus k into alpha plus beta into x plus k alpha beta. Now comparing the coefficient with this, that is ax square plus bx plus c, comparing the coefficient of this, what you get? A is equal to k, b is equal to minus k into alpha plus beta, and c is equal to k alpha beta. Okay, when you compare these things. Now, b upon a, when you want b upon a, that is minus k into alpha plus beta upon k gets cancelled and you get alpha plus beta, and you shift this minus to this side and you get this. That means the sum of the roots. What is this alpha plus beta? Alpha plus beta is equal to minus b upon a. That is sum of the roots is equal to, sum of the roots is equal to, what is your b? Here b is the coefficient of x minus the coefficient of x upon what is a? The coefficient of x. Now I want the product of the roots, that is alpha into beta. So where it is alpha into beta, it is here. So C upon A is equal to K alpha beta upon A is this. I want only alpha beta. So I have to divide that K alpha beta by something. So what I will divide? It is A itself, because B has minus K and alpha plus beta. So C upon A will be alpha beta. Therefore, alpha beta is equal to C upon A. The product of roots, product of zeros is equal to minus, what is your C? That is C is minus constant term upon coefficient of x. Constant term upon coefficient of x. Okay. They have explained it everywhere, the same thing in this page. How you got alpha plus beta, and alpha beta is equal to C upon E. Now for cubic polynomial. What you are going to do? For cubic polynomial. What is the cubic polynomial standard? What is the standard form of cubic polynomial? Ax cube plus bx square plus cx plus d equal to 0. Here, till now you have this roots of alpha and beta. Roots are alpha and beta. Now for cubic polynomial, but obvious है कि तुम्हारा 3 roots रहेगा, so it will be alpha, beta and gamma. Alpha, beta and gamma. Alpha, beta and gamma. Okay, and here also A not equal to 0. Now you want the additions of alpha, beta. One of the sum they have given us for the cube root. Example they have given us of the cube root, so I am explaining this here. Here alpha plus beta plus gamma is equal to minus coefficient of x square upon coefficient of x cube. Okay. So alpha plus beta plus gamma is equal to minus b upon e. What is alpha? Product? Product is, I'll write it here. Alpha beta plus beta gamma plus gamma alpha. Plus gamma alpha is equal to coefficient of x upon coefficient of x. Okay, that is equal to C upon D. So alpha beta plus beta gamma plus gamma alpha, you get C upon D. Now the remaining is alpha, beta and gamma. That is the minus constant term upon coefficient of x cube. That is alpha, beta, gamma is equal to alpha, beta, gamma is equal to minus d upon that. When you have cube, cube root, that is alpha plus beta plus gamma, is equal to minus b upon a. Then the product of all the three roots are alpha beta plus beta gamma plus gamma alpha, that is c upon d. And alpha beta gamma product is equal to minus b upon d. They have given us the examples. Find the zeros of the quadratic polynomial and verify the relation between the coefficient. Zeros, that is x square plus 7x plus 10 by middle term splitting. By middle term splitting, that is x plus 2 and x plus 5. You get, and the zeros are x equal to minus 2 and x equal to minus 5. So what you are going to get is sum of the zeros, minus 2 and minus 5 is minus 7, minus outside, then coefficient of x is 7. See here you have got it. Then the product of zeros is minus 2 into minus 5, that is 10 upon 1, and the constant term of the coefficient. We will see one more example here. Find the zeros of the polynomial x square minus 3. Okay, and verify the relation. What is that? X square minus 3. So p of x is equal to this. That will be x square minus root 3 square. And you can use the formula a square minus b square, and that is a plus b and a minus b. So what is that? X minus root 3 and x plus root 3. And therefore, x minus root 3 equal to 0 and x plus root 3 equal to 0. X equal to root 3 and x is equal to minus root 3. Now what we have to see is, we have to verify it. We have to verify the relations. Sum of zeros. Sum of zeros. That is alpha plus beta is equal to minus b upon a. That is equal to, what is your b term here? It is 0. 0 upon 1 is 0. And here see, sum of the roots, that is root 3 plus or minus root 3, and you get 0. Have you verified? Yes. Then product of zeros is equal to product of 0, that is c upon a, that is 3 upon 1, that is 3. And when you verify it's root 3 into root 3, you get is 3. Hence verified. Find the quadratic polynomial, the sum and the product of whose zeros are minus 3 and 2 respectively. Minus 3 and 2 respectively. They have given, now here they have given us the zeros of the polynomial, that is alpha is equal to, they have given the sum and the product, that means alpha plus beta is equal to 2 minus 3 and alpha beta is equal to 2. Here alpha plus beta is equal to minus 3, that is equal to minus b upon a, and alpha beta is equal to 2, that is equal to c upon a. From this we can see that b is equal to 3, a is 1. If nothing is there in the denominator, we put it as 1. So here a is equal to 1, b is equal to 3, and c is equal to 2. And c is equal. And what is your standard form? Ax square plus bx plus c. A is 1, x square is x square, b is 3x, and c is 2. So this is the how you get the equation. In this way you can get the equation of that. Again they have given us the example, that is alpha, beta and gamma, what I said it earlier. See, here they have given us alpha plus beta plus gamma is minus b upon a. Then this is Alpha beta plus beta gamma plus gamma alpha is C upon A, and alpha beta gamma is minus D upon A. Verify that 3 minus 1 and minus 1 upon 3 are the zeros of the cubic polynomial. So they give cubic polynomial, that is 3x square minus 5x square minus 11x minus 3. And then verify the relation between the zeros and the coefficient. See here, they have, first of all they have compared it, what is A, what is B, what is C and what is D. Then what they have done is alpha plus beta plus gamma. First of all, they have shown us that substituting the value of x, what they get, that is 0. So, yes, these are the zeros, verified it. And then the relations they have shown it, okay. Not from the exam point of view, they have written here, but in some schools, they give the examples of cubes and also we have to do it. Now, exercise 2.2. Before starting the exercise, I'd like to show you some example. Before starting for the exercise, extra example I'm showing you, not in the textbook. If alpha and beta are the zeros of the polynomial x square minus p into x plus 1 plus c, such that alpha plus 1 and beta plus 1 equal to 0, then you have to find C. What is the example? If alpha and beta are the zeros of the polynomial, this is your polynomial, such that alpha plus 1 and beta plus 1 equal to 0, then find the value of the polynomial. First of all, we will compare this with our regular polynomial, where A is equal to, I'll write it here so that ax square plus bx plus c, and on comparing we get a is equal to 1, b equal to minus p, c here. Before writing it minus p, I have to tell you one thing here. I'll compare it afterwards. Before going to that, they have given p into x plus 1. I'll just split up. Minus px minus p plus c. Now comparing with ax square plus bx plus c. Now see what you get. A is equal to 1, b equal to minus p, and c is equal to minus p plus c, and that is c minus c. And before this I was getting minus p into x plus 1. So before that I have split up the bracket. Now what you get? Alpha plus beta. What is alpha plus beta? That is minus b upon a. So minus b upon 1, that is minus of minus p. Minus of minus p, you get alpha beta. C upon a. C upon a, that is c minus p upon 1, and you get c minus. You have come to here. Now what they have given, that such that x alpha plus beta and alpha plus 1 and beta plus 1 is equal to 0, then find this. So before that, what I am going to do is alpha plus 1 and beta plus 1. They are the two binomials, multiply these two binomials. That is alpha plus beta plus 1 equal to c. Alpha into beta, alpha beta. Alpha into 1 is alpha, then 1 into beta is beta, and 1 into 1 is 1. So I have written this. What is your alpha beta? That is c minus p. What is alpha plus beta? That is p plus 1 equal to 0. cancel it, and c plus 1 equal to 0 and c equal to minus 1. So what you have got the value of c? That is c equal to minus 1. The value of c is minus. Now we start with our exercise, that is 2.2. Find the zeros of the following quadratic polynomials and then verify the relation. First of all, exercise 2.2. First one. Now here all the sums are same as we'll do the first one. No, all the sums are same as first one. First of all, here what we are going to do is we'll split up the middle term. 8 x square minus 4x plus 2x minus 8. X square plus this minus 8. That is x, sorry, x plus. So what are the zeros? When p of x equal to 0, that is x minus 4 equal to 0 and x plus 2 equal to 0, you get x equal to 4 and x equal to minus 2. So what are the zeros of this? Zeros are 4 and minus 2. Now you have to do the verification. That is sum of zeros is equal to sum of zeros 4 plus minus 2 you get is 2. Then what will it become? Minus of minus 2. When you get the 2 minus of minus 2, that is minus into minus is plus, and that is minus b upon 8. See here, this minus and this minus is constant, so your b will be minus 2. See here. Product of zeros is equal to 4 into minus 2, that you get is minus 8. So it is c upon e. Hence here rest of the sums are same as the first one, so you can do it. First of all, middle term splitting because I'll show it x square minus t square. That is the sum is fifth one. I'll show it here only. Fifth one sum, that is t square minus 50. That is t is equal. You can do in this method also. T square is equal to 15 and t equal to taking out the square roots. You can get this. Taking square roots, you can get this. Therefore, your roots are plus 15 and minus 15. Okay. Zeros are this. So what is the verification? Sum of the zeros, that is alpha plus beta. Root 15 plus of minus root 50. You get 0. That is equal to b upon a. See here, you don't have any bt. Alpha beta, root 15 into minus root 50. You get minus 15 and that is c upon e. Hence, verified. Okay. In this way, you can do the rest of the sums. Now, question 2. What is question 2? Find the quadratic polynomial, each with a given number as a sum and product of the zeros respectively. Find the quadratic polynomial whose sum is given and the product is given. Okay. What is the your sum? First one is 1 upon 4 and minus 1. Question 2. Sum, that is alpha plus beta is equal to 1 upon 4 and alpha beta is minus 1. Then your quadratic polynomial, then the quadratic polynomial will become. This is also formula 1, x square minus alpha plus beta into x plus alpha beta plus alpha beta. What is your x square? Same as it is. Alpha plus beta is 1 upon 4 into x plus alpha beta is minus 1, and you get is x square minus 1 upon 4x minus 1. The k will remain the constant, and k LCM, do the LCM, that is 4x square minus x minus 4, and if k equal to 4, the required quadratic polynomial is required quadratic polynomial is 4x square minus x minus 4. Okay. The second one also I will do for you, and then the rest you can do. That is root 2n minus 3. Same thing. Alpha plus beta is root 2, and alpha beta is equal to minus 1 upon, so it is plus. Again the quadratic, again you write the same thing. The quadratic polynomial k x square minus alpha plus beta into x plus alpha beta, that is k x square minus root 2x plus 1 upon, again same thing, LCM, that is 3x square minus 3 root 2x plus 1, and therefore the required polynomial is 3x square minus 3 root 2x plus 1. So in this way you can do the rest of the sums. Okay. In next lecture we will continue with our further division algorithm of polynomials.